I'm Courtney.
Hello, I'm Derrick.
I'm Elsa.
And
Welcome to Neuronia. Yay!
Part 1. What is a neuron?
Neurons are the basic unit of the nervous system. Neurons communicate with one another and with other cells. These are the different parts of the neuron. A neuron has dendrites, a cell body, aka soma, nissel bodies, nucleus, axon, Schwann cells, and synaptic cord. We can also see the sodium channels and potassium channels.
Part 2. How does a neuron work?
Before we get started, let's get familiar with the beans and the pasta. Over here, let's see. The black beans represent the sodium ion. Red beans represent the potassium ions. White beans represent chlorine ions, and the pasta represents anions. This is the outside of the neuron with mostly white and black beans, while the inside consists of mostly red and pasta.
Stage A, the cell currently is in resting state. The sodium gate is closed and the potassium gate is closed. And the resting membrane potential is currently around -70 millivolts. Now, outside of the cell, there's a positive 7 charge, whereas the inside of the cell has a -9 charge. So right now we're going to initiate the action potential. There's going to be a stimulus that's going to rush through the cell. And this is going to open the sodium channels. So we're going to make the sodium channel open. Now the sodium channel is open, and now sodium ions, which are the black beans, are going to diffuse across the membrane inside to help make it more positive inside the cell. It's just going to be depolarizing the cell. So 15 sodium ions are going to be going inside the cell. This is 10, 13, 14, 15. And that leaves about 3, 6, 7, 8, 9, 10, 11, 12, about 14 to 15 sodium ions still left outside the cell. And this change in charge is the depolarization process. And this ends up leaving the cell at a positive 6 inside and a -8 outside of the cell.
The depolarization process then causes the potassium channels in the plasma membrane to open and the sodium channels to close. So the sodium channels close and the potassium channel opens. As the potassium channel opens, 15 potassium ions rush out of the neuron. This constitutes the repolarization process because the outside is now positive.
So after the repolarization process, active transport moves the sodium and potassium back to the initial state. And the time it takes to move back to the initial state is known as the refractory period. So we're going to move some of the potassium ions back across the membrane, and it's going to close again. And then we're going to move some of the sodium ions back across the membrane as well, bringing it back to its original state. Thank you for coming to Neuronia.